Okay, so in this problem, let's try to prove that if you add up the first n integers, 1 plus 2 plus 3, dot, 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 where the nth term is n, that you could use the formula n times n plus 1 over 2. That's what we're trying to prove. Remember that this is the an, and this is Sn. Right? It helps to just label that and get that, because you're going to use both of those in a minute. What's the first step? Make sure it works for n equals 1. So let's see. S1 equals, and now I'm plugging into that formula, 1 times 1 plus 1 divided by 2, which is 1 times 2 over 2, which is 1. Okay? That's what the formula says the sum of the first term is. What is the sum of the first term? It's 1. So that checks. Right? We did that part. Okay. Next, I would always do this then. I would write down this. Sk plus ak plus 1 equals sk plus 1. That is always true. If you take the sum of the first k terms and you add the next term, you have the sum of the first k plus 1 terms. Now, we need to be able to, let's figure out what is sk. If this is Sn, what is sk? If this is the formula for S sub n, then what is S sub k? Yes. K times k plus 1 over 2. Just put in the place of n, k. Okay, now we need to know the ak plus 1, right, here. So how do I find ak plus 1? Well, here's the formula for a sub n, k plus 1. Just put in the place. It's kind of like evaluating a function, right? So ak plus 1 must be k plus 1. Okay, now we need sk plus 1. How do I find sk plus 1? Say again? How do I find, if this is the formula for Sn, how do I, no, you don't just add 1. You substitute k plus 1 for n, right? You got to, sk plus, this is S sub n. So it's kind of like evaluating a function. Whatever is here goes in the place of n. So that is k plus 1 times k plus 1 plus 1 over 2, right? I just put in the place of n here and here, I put a k plus 1. And now I can simplify that. That is k plus 1 times k plus 2 over 2. Okay, now let me plug in, let me substitute here. Sk we said is k times k plus 1 over 2. Ak plus 1 is k plus 1. And sk plus 1 is k plus 1 times k plus 2 divided by 2. Okay, and that's the thing I don't know is true. I have to show that that's true. Okay, now at this step, you can try to just work on the left side and make the left side look like the right side, or you could try to make the right side look like the left side, or you could just try to work on both sides until they meet in the middle, and they definitely are equal. And each problem can work out a little bit differently. What do you think would be a good first step to solving this one? Okay. Simplify numerators. Well, you don't have a numerator over here. You got two different terms. You could do that. Yeah, I think a good first step, like we did with rational functions at this point, multiply everything by 2 to get rid of the denominators. right? Multiply this by 2, multiply this by 2, multiply this by 2. Okay, that cancels these two. And now we've got this. K times K plus 1 plus 2 times K plus 1 equals K plus 1 times K plus 2. Again, that's still a question mark. Okay, let's work on the left. Distribute. K squared plus K plus 2K plus 2. Combine like terms. K squared plus 3K plus 2. Okay, now, that's a simple factoring problem. You could just say, what two numbers, the product is 2 and the sum is 3, and you would say 2 times 1, right? So it'd have to be K plus 1 times K plus 2, which is exactly the right-hand side. So at that step, you just made the left side look like the right side. So you're done, right? If you have trouble factoring, you could choose instead to just FOIL the right side, right? If you don't have to make the left look like the right. You can make them meet in the middle. So maybe you get to this point here, and you say, okay, let me FOIL this. Then I will get K squared plus 2K plus K plus 2. That's K squared plus 3K plus 2. And that's the same thing. So that's another way to check it. So you could either factor from here, or you could FOIL that, but just make sure the left-hand side equals the right-hand side. Now that we've done that, we assumed that it worked by using the formula for SK. We assumed it worked for N equals K, and we showed that it works for K plus 1. Therefore, it works for all values of N. That's math induction.